Do you want to see how to import or create a geometry from Python, or even more, how to create a model input file from script? Welcome to my first user interface devlog. Let's create two simple meshes using Python scripting inside our custom mesh user interface. Here at the bottom right, we have the user interface console in which we run Python commands. First, we import the module and then create a mesh. Later, we define the nodes and the quad elements with the connectivities. After this, create the part from mesh. After this, we create another same quad but with a higher position on the z-axis. We rename here the things and create another mesh and part. But wait, something didn't look right. Turns out, there was a small bug in the graphic user interface connectivity assignment. I opened an issue and patched it. Here you can see the issue. The problem was in the node element assignment. After the fix, everything works as expected, as you can see here. These scripting workflows made it easy to test, debug, and automate mesh generation directly from Python. What if you want to create a primitive geometry like this cylinder from Python commands? I want first to create a geometry library which contains both the visualization and data separately. For this, I have created a separate folder with all CMake files which are our build system. Then I add to this include SWIG file, which is an automatic Python library creator from C and C++ code. Here I add my custom geometry and visualization via VTK library. Then I include all to be linked to our Python library. We can see here some errors requiring OCC shared files. OCC is the library which manages the geometry creation. Once added, this leaves it links OK, and we can see our Python file. Then we can see here our command consoles in which we generate our cylinder from this dummy command, and we can see we effectively generated. You can see the cylinder is generated, but it is not seen on the screen. Why? Here I have put a single button in the editor in which not only the cylinder is generated, but also is shown correctly. The way we show this is via VTK actors, so if we add this actor, the cylinder shows. This actor management is internal in the case of parts, and I will create a geometry class to handle this, which will come in the following devlogs. Previously on my channel, I have shown how to create a job, which is basically a simulation run that starts from an input file in JSON format. We also saw how you can monitor the progress in this simulation directly through the user interface. This time, we will go one step deeper and look at how to generate that input file from code. If we want to run a job, the first step is to create the input file. To make this process reusable, I'm wrapping a specific C++ function that handles input generation. Here, I'm writing the function outside the class constructor, although originally it was embedded here. This change makes the code cleaner and more modular. Now, anytime I want to write a new input file, I simply call this dedicated function. In the constructor, I only keep the reference to the model. That's it. This separation of concerns allows us to maintain clarity and avoids duplication when handling different models. Once the function is in place, we compile the code. This step builds the executable or the shared lib library needed by our simulation backend. At this point, we've automated the first half of the job creation process. Now I'm opening a test file called wow.json. This is a file where we will create the input content. In the build system, I add a command that replaces the old Python library with a new one, which now lives inside a subfolder of our project. This lets us keep the structure organized while still ensuring everything looks currently. Then I run the make command to build the project. The first time I do this, it fails. The system tries to copy a file before it's being created. But if I run a second time, it works, since the file now exists. To confirm, I check the binary output folder and verify that the file has been copied successfully. Finally, I run a Python command inside the console. This triggers our wrapped function, and we see that the JSON input file has been written correctly. If you're into FEM, SPH, CFD, remeshing, or just enjoy watching solids get squished by clever math, you're in the right place. I dive into open source solvers, CPU acceleration, and how these methods actually work under the hood. So hit subscribe, or better, hop on the mailing list at opensourcemac.com. No spam, just good stuff. And if you want to support or ask deeper questions, there's always my Patreon. Thanks for watching and happy coding!